So dear students, welcome to the Medicaps learning series. I am Dr. Bidhan Hazra, Assistant Professor of Chemistry in Medicaps University, Indore. So today I will discuss on the basics of spectroscopy. Now the first question arises is, what is a spectroscopy? So spectroscopy is the topic where we discuss the light-matter interaction. Now, for spectroscopy, we generally try to understand the properties of matters, say for example a molecule or atoms, through shining light and then recording how the interaction happened. Now, from the topic's title, you can see there is a term, one is called spectra and one is the scopy. So actually you will visualize something through spectral analysis. What is a spectra? Spectra is when you plot a wavelength and intensity plot, and then you try to understand what actually happened during the interaction. Now that means, so for the spectroscopy, you must have light first of all. Then the light will fall into matter. Then after the interaction, here will be the interaction. Then after that, you will detect it. So you need a detector. This is the basic of instrumentation of the spectroscopy. So you need a light source. Then the light will fall onto a matter. Matter might be a molecule, a liquid, a solid, atomic state, like this. And then after the interaction, there will be a detector. So in the detector, you will detect the scattered light or the emitted light, like this. So now, depending on the light's characteristics, the nomenclature happens. For example, light can be of many types, like depending on its wavelength or frequency or energy. For example, it might be X-ray, it might be UV, ultraviolet, it might be visible, infrared, radio, frequency. So these all are electromagnetic wave. Means electric field and magnetic field when they are propagating as a function of time perpendicular to each other. So if it is an electric field, then in its perpendicular plane, there will be a magnetic field. So here it is actually a plane polarized light. Now when this light interacts with matter, different phenomena happens during this interaction. It might be absorption, it might be scattering, it might be emission, and so on, like this. And detector also, depending on what is your point of interest, you detect accordingly, you place your detector according to that. Interestingly, if we look at the different type of lights, so there are spectroscopy, which is called UV visible spectroscopy, IR spectroscopy, or microwave spectroscopy, and radio frequency is also possible. Now, depending on the interaction also, there are absorption spectroscopy, scattering spectroscopy, for example, Raman scattering or Rayleigh scattering, or emission spectroscopy or fluorescence spectroscopy. So this is the part of the initial basic thing regarding the spectroscopy. Now, after the interaction, when you detect in the detector, after the detection, you actually process it. Now, through the computer. Now, then you plot a parameter, say intensity, it might be a scattering intensity or an absorbance as a function of wavelength, some people do frequency, some people do energy also. So in any format, they can plot it. From this spectra, actually, you will have like this. Analyzing these things, you can understand what type of interaction and in which particular wavelength or energy the interaction happened. Now we will move to a specific example. Say you want to study non-absorption spectroscopy. What happens here is, say you have a light source, it will fall on a matter. After the interaction, you will detect, after the interaction, that means some light is already absorbed by the matter. After that, what you will detect is which was actually not absorbed, because you cannot measure directly which was absorbed. So it is like an indirect measurement. From the light, so you have the intensity of the incident light, and after the interaction, you will have an intensity of I. Depending on these two parameters, you can calculate how much was absorbed. So in this way, absorption spectroscopy works. Now, after the detection, you process the data and you will get a plot, say A. A has no unit, it's an absorbance, and as a function of lambda, or that is wavelength, you get a spectra. This is called absorption spectroscopy. Now, in the similar fashion, when light falls on a matter, as per the quantum mechanics, so I must say here that spectroscopy and quantum mechanics is very much connected. So molecules have different energy states. Once the light falls on the matter, it excites the molecule and it goes to a higher state. And then after staying there for a very small amount of time, in the range of say picosecond or like this, or nanosecond, it comes down. Now when you comes down, you actually measure the emission. When you detect this light, that is called an emission spectroscopy or fluorescence spectroscopy, which will actually have a different frequency than its excitation. So that is called an emission spectroscopy. Now, there is, and it is, say it is an ground state and this is an excited state. It is also possible that someone may be interested in scattering spectroscopy. What does it mean? It means that you will shine the light. Say for example, you take, it falls on the matter. You will detect only the scattered light, not absorption or emission. This scattering can be of two types. It might be Rayleigh scattering or it might be Raman scattering. Rayleigh scattering means if the light after the interaction scattered with the same frequency, then it is called a Rayleigh scattering. It may happen that the matter takes some energy from the light. It also may happen that matter is giving some energy to light. So these two different light will be scattered from the matter after the interaction. They are called Raman. One is Stokes and one is anti-Stokes. Depending on that, this scattering spectroscopy was invented. The Raman's, Chandrasekhar Venkata Raman, who is an Indian, the first Nobel Prize in Science came in India in 1930, actually on the scattering spectroscopy. So this is called scattering spectroscopy. So you detect the scattered light. So these are the basics, very basic part of the spectroscopy and different type of spectroscopy. Interestingly, actually, now we will talk a little bit about its application. Actually, spectroscopy is so wide, so it has a application is so wide that it requires in medical science to astrophysics. Just think about the astrophysics. That it's not possible to detect, it's not possible to send a person to a star or to a planet which is like millions of miles away from the Earth. So what happens? The scientist tries to detect what are the different type of signal, like light signal or electromagnetic signal is coming from those stars or galaxies or planets or any other extraterrestrial bodies, and try to analyze those spectra, signals. So it is important there. And not only that, we all know that there is something called MRI, that is magnetic resonance imaging. This magnetic resonance imaging is very common in medical science. So it is also based on all this and imaging. It's not the direct spectroscopy, but it is based on the principle of this NMR, that is nuclear magnetic resonance spectroscopy. Here the light that is used is an radio frequency wave, and when the particular molecule, say hydrogen atom, is placed in strong magnetic field, its energy level gets splitted, then you send the radio wave and excite the spin. So it is actually interaction with the nucleus, not with the electrons of the molecules. So it is a different kind of spectroscopy where we deal with very long wavelength light, that is radio wave, with the nucleus. Its direct application is magnetic resonance imaging. So whatever we have discussed till now is the very basic of spectroscopy, its fundamentals, its categories, and its application in medical science or other fields. So today this is up to this. So for more videos, you can follow the Medicaps learning series in this channel. Thank you.